For this problem, we have three charges that are fixed. So we have Q1, which is at the origin, Q2, which is at x equals 1.5, so this distance is 1.50 meters. And then we have a charge Q3 up here, which is positive. And this distance is 2.4 meters. Now that makes this distance 2.83 meters, right, from the Pythagorean theorem. And then this angle theta, I call that angle theta, that angle theta is the inverse tangent of opposite over adjacent. That's 58 degrees. Alright, what we want is the magnitude and direction of the net force on that charge Q3. So we have, this is F1, which points down at that angle theta, down below the horizontal, and then we have a force F2, which is repulsive as a result of charge Q2. Alright? So we just need to figure out the magnitudes of these two forces. We've got the directions drawn, and then we need to combine them. So we'll start with F1. So the magnitude of F1 is K Q1 Q3, or R13 squared. That is, there's the Coulomb constant. Now Q1 is given to be 4.0 microcoulombs, and Q3 is given to be 2.2 microcoulombs. And we're dividing it by our distance, 2.83 squared. So that force is 9.89 times 10 to the minus 3 newtons. Now, notice I left the minus sign there off of Q1, but that's because I'm just calculating the magnitude of the force, right? Do the same thing for F2. F2 is going to be K Q2 times Q3 divided by that distance squared. And that works out to be 1.89 times 10 to the minus 2, or 18.9 times 10 to the minus 3 newtons. That way, I like writing them that way so they both have the same exponent. Alright, so sum of the x forces is the x component of F1 plus the x component of F2. The x component of F1 is minus 9.89 times 10 to the minus 3 times cosine 58 degrees. Now you notice this minus sign. That's because our sign convention is that to the right is positive and to the left is negative. And since F1 here points in the minus x direction, that's where that minus sign comes from. So that x component is, and of course, the x component of F2x is 0, right, because F2x points straight up. So this is minus 5.24 times 10 to the minus 3. And then the sum of all the y forces is F1y plus F2y. Now F1y is also negative. It's negative 989 sine 58. But then the y component of F2 is positive 18.9 times 10 to the minus 3. So that works out to be 10.5 times 10 to the minus 3. Okay, so there's my x component and my y component of the resultant. If I draw a little coordinate system down here, we're going to go 5.24 in the minus x direction, and we're going to go 10.5 in the plus y direction to get our resultant. There's going to be some angle alpha here, I guess. This is our total force. And so the magnitude of the total force is the square root of, I guess, 5.24 squared plus 10.5 squared. And we'll multiply that times 10 to the minus 3, so that's that's 12 times 10 to the minus 3. And then the direction alpha is inverse tangent of 10.5 over 5.24, which is 63. So our final answer is that the force is equal to 0.012 newtons in a direction 63 degrees above minus x. So I want to point out that, of course, in the tangent function here, I did not use negative 5.24, right, because this is just the side of a triangle here, 5.24. I've already decided from my diagram that my angle was going to be above the minus x direction. If you put a negative sign here, then your calculator is going to think your vector points down like that. So we've done this sort of thing, combining vectors back in mechanics, right? So we're done.